Hello everyone, let's work towards solving the question number 5. Question number 5 asks you which of the following represents a function, and we have to explain the reasons as well. Now for different scenarios, there are different techniques to check whether the given question is a function or not. For example, when we have a graph, we have something known as vertical line test. It means that if you draw a vertical line on the given graph at any point, it should not cut 2 points of the graph with the same line. For example, if I draw the vertical line in here, now if you'll see, just with this one straight line, I can cut 2 points on the graph, one in here and another in here. So part A is not a function. It is not a function. What is the reason? The reason is the vertical line test. It does not pass the vertical line test. Another reason can be written as when a vertical line is drawn, it cuts the given graph at more than 1 point. So specifically at 2 points. Now, what kind of graph representation is going to be a function? For example, if I draw an upwards parabola, something that looks like this. Now, on this parabola, if I am going to draw a vertical line at any point, like here, here, or here, anywhere on the graph, it is only cutting my graph at 1 point. Every line is cutting my graph at 1 point only. That means this is a function. Why? Because it passed the vertical line test. So whenever a graph is given to you, what you have to do is just draw a vertical line, and a vertical line can be drawn at any point on the graph. And if at every point on the graph it is cutting only 1 point, then it is a function. And if at any point on the graph it is cutting more than 1 point, it is cutting the graph at more than 1 point, then it is not a function. Let's move on to question number 2 now. Question number 2, if you'll see carefully, is a quadratic equation. Now let me just simplify this quadratic equation. This is y is equals to 2. If I'll open it with the formula of x minus b whole square, to recall you guys, the formula of a minus b whole square is a squared minus 2ab plus b squared. I'll just write it here, plus b squared. That means here my a is x and my b is 1. So a squared is x squared minus 2 times a, which is x, times b, which is 1, plus b square, which is 1 square. Perfect. Plus 3. Now the next equation is 2x squared negative 2 times x is 2x times 1 is 2x. 2x plus 1 is equals to 3. Then I'll be having y is equals to, I'll just multiply 2 inside the bracket. So I'll have 2x squared minus 2 times 2 is 4x plus 2 times 1 is 2. And here it should be plus 3. Now if I solve it further, it is going to be written as y is equals to 2x squared minus 4x plus 2 and plus 3 becomes plus 5. Now any equation that looks like this, that means that imitates the standard equation of a parabola, that is y is equals to ax squared plus bx plus c. Signs can be different, but any equation that looks like this is definitely a function, is always a function. It is always a function. Why? Because this equation tells you that for every value of x, there exists only one value of y. If for every value of x there exists only one value of y, then that equation is a function. By default, all parabolas, as I've shown you in part A, is a function. So all equations that imitate the standard equation of a parabola, those all equations will be functions. So second B part is a function. Why? Because for every value of x, we have exactly one value of y. So B is a function. Part C, if we look at here, we have two signs, plus and minus. What is the meaning of this? See, I'll just distribute the values as plus and minus means that there are two possible values of y. y can be plus square root x minus 4, or y can be negative square root x minus 4. Oh, minus 4. Now if you'll see here, for example, at x is equals to 4, if I'll put x is equals to 4 here, that means my y is going to have two values, which is first of all plus square root 4 minus 4, second minus square root 4 minus 4. That means y will have either, like, square root 4 is 2, so plus 2 minus 4, or it will have value of negative 2 negative 4. So plus 2 minus 4 is negative 2, negative 2 negative 2 is negative 4. That means for one value of x, I have more than one value of y. For one value of x, I have more than one values of y. That means this is not a function. So now I hope you've got the trick that whenever an equation is given to you, you have to verify only one thing, which is for every value of x, there should be exactly one value of y, only then it is a function. And if this is not the case, if for one value of x you are getting two different values of y, then this is not a function. Now let's move on to part D. Now you tell me, what do you think? See, at D, we have y is equals to 2 raised to the power x minus 4. If I put any unique value in the place of x, I will get a unique y. So without putting any value, can I say that for every particular value of x, there exist, this is the sign for there exist in maths, there exist only one value of y? If this statement is true, which is true according to my knowledge, but I encourage you all to check, replace x with different values and just try to see whether you're getting only one answer for y or different answers for y. I am positive that when you'll experiment, for every particular value of x, you will get only one value of y. Hence, this is a function. Now for part E. For part E also, see, if I'll just replace x with any particular angle, say 120 degrees. Let me just randomly put x at 120 degrees. So y is going to be equals to cosine of 2, 120 degrees minus 30 degrees, plus 1. Plus 1. That means y will be equals to cos 120 minus 30 is 90 degrees, and 2 times 90 degrees is 180 degrees. 180 degrees plus 1. Now, however I'm going to calculate this, the answer for this is going to be only one value. Cos is a function. If you remember the graph of the cos, it is something like this. Now through the vertical line test, if I draw a vertical line anywhere on this graph, the graph is going to cut, the line is going to cut the graph at exactly one point. Hence, this is a function. Since this is the equation of cos, this is a function too. But since the equation is given to us, under explanation we should write, since for every particular value of x, there is only one value of y, hence this is a function. This is the end of question 5. I hope you have understood how to define or prove whether a given graph or an equation is a function or not. Thank you so much for watching this video. I'll see you in the next one. Bye-bye.